In this episode, we move from prevention into response, and we focus on two closely related programs that determine whether an organization can contain AI issues quickly: problem management and incident management. If you are new to cybersecurity, the word incident might make you think only of major breaches that hit the news. In real organizations, incidents also include smaller events that still matter, like a system exposing data, producing unsafe outputs, or being misused in a way that could escalate. Problem management is the discipline of finding the deeper causes behind repeated incidents and fixing the underlying conditions so the same failure does not keep coming back. Incident management is the discipline of detecting an event, deciding how serious it is, coordinating a response, and restoring normal operations. AI makes both programs more challenging because the failure modes can be subtle and can look like normal usage at first. Your goal is to learn how to evaluate whether a program is set up for fast containment when an AI system is abused, misbehaves, or leaks information. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good way to begin is to define what counts as an AI incident versus an AI problem, because organizations often mix these up and lose time. An incident is a specific event or series of events that requires a coordinated response, such as a model outputting sensitive data, a prompt injection attack succeeding, a tool integration being misused, or a model endpoint being probed for extraction. A problem is an underlying cause that makes incidents possible, such as overbroad retrieval access, weak prompt governance, missing monitoring, or a pipeline that allows unsafe updates. Fast containment depends on noticing the incident early and taking immediate steps to reduce harm. Long-term safety depends on identifying the problems that allowed the incident to occur and fixing them so the same pattern does not repeat. When you evaluate a program, you want to see that it can do both. Handle the immediate event with speed and clarity, and then learn from it in a disciplined way. If a program only fights fires without fixing causes, the organization will face repeat incidents. If a program only studies causes but cannot contain quickly, the damage will accumulate before improvements take effect. Detection is the first stage of incident management, and AI incidents often require detection methods that go beyond traditional IT monitoring. A model can be abused through normal-looking prompts. A retrieval system can leak information through ordinary questions, and a model can be manipulated without any malware. So the evaluation question is whether the organization has monitoring tailored to AI behavior, such as alerts for repeated bypass attempts, unusual retrieval patterns, abnormal tool calls, and spikes in query activity that suggest extraction or probing. You also want to see whether there are channels for humans to report issues, because in many AI incidents, a user noticing a wrong or unsafe output is the first signal. A mature program treats user reports as valuable telemetry, not as noise, and it has a clear path for routing those reports to responders. Detection is not only technical, it is also social, because people need to know what to report and how to report it without fear of being blamed. Fast containment starts when signals are captured early and reach the right team quickly. Triage is where an organization decides what the incident is, how serious it is, and what to do first, and this is a place where AI programs often struggle. Traditional triage often asks whether systems are down, whether data was exfiltrated, and whether malware is present. AI triage must also ask whether outputs caused harm, whether sensitive data was exposed through responses, whether retrieval pulled restricted documents, and whether the model was manipulated into unsafe tool actions. Another AI-specific triage question is whether the incident is ongoing and scalable, meaning can an attacker repeat it easily, and can it affect many users? If an exploit requires rare conditions and affects only one user, containment options may be different than if it can be triggered by anyone with access. Evaluating triage means checking whether the program has criteria that match AI risks, not just generic IT incident templates. You also want to see whether the organization can quickly identify which model version was involved, which prompts and configurations were active, and which data sources were connected at the time. because those details drive containment decisions. Containment is the heart of incident management, and for AI it often means limiting capabilities rather than rebuilding servers. If a model is leaking data through retrieval, a fast containment step may be to disconnect the retrieval source, restrict it to a safer subset, or enforce user-based access checks. If a model is being abused through prompts, containment might include tightening policy filters, adding stronger prompt sanitization, increasing rate limits, or temporarily blocking certain categories of requests. If tool integrations are being misused, containment might mean disabling tool actions, requiring additional approval for tool calls, or restricting which users can trigger tool use. If keys are suspected to be compromised, containment includes revoking or rotating those credentials quickly and checking for continued abnormal activity. The key evaluation point is whether the organization has predefined containment actions for AI systems and whether it can execute them quickly without breaking everything. Fast containment depends on having control levers that can be pulled during an incident, not just after an incident is over. Communication and coordination are another area where AI incidents can go wrong, especially because different teams may own different parts of the system. Engineering might own the application, data science might own the model, platform teams might own infrastructure, and security might own monitoring and response coordination. If roles are unclear, valuable minutes are lost deciding who is responsible. Evaluating incident management includes checking whether there is a clear incident commander role or equivalent coordination function, and whether the program defines who must be involved for AI incidents. You also evaluate whether communication includes business stakeholders, because AI incidents often have business impact through decisions, customer trust, or regulatory exposure. Another important point is message discipline. Responders should use consistent terminology and document decisions as they happen, because confusion leads to duplicated effort and missteps. For beginners, this matters because it shows that incident response is not just technical skill, it is also teamwork under pressure. A mature program trains for coordination, not only for technical fixes. Recovery is the stage where the organization restores normal operations safely, and for AI that requires careful thought about what it means for the system to be trustworthy again. In a traditional outage, recovery might mean restarting services and confirming systems are back online. In an AI incident, recovery might require verifying that the model configuration has been restored to a safe state, that prompts and system instructions are correct, that retrieval sources are properly restricted, and that keys have been rotated. It might also require validating that the model no longer produces the unsafe behavior or that the bypass technique no longer works. If a model version is suspected to be problematic, recovery might involve rolling back to a previous version and confirming performance and safety. A strong program has a concept of recovery criteria, meaning it defines what evidence must be present to declare the incident resolved. Evaluating recovery means checking whether the organization can test and validate fixes, not just deploy changes quickly. Fast containment is important, but unsafe recovery can create repeat incidents. Now let's connect this to problem management, which is the discipline that prevents the same incident class from repeating. After an AI incident, the program should perform a root cause analysis, but not in a way that becomes blame-focused or overly theoretical. Root cause analysis should identify what control failed or was missing, such as inadequate access segmentation, weak monitoring, insufficient prompt governance, or a pipeline that allowed risky changes. It should also identify contributing factors, like unclear ownership, missing documentation, or lack of testing for known abuse patterns. Problem management then tracks corrective actions, assigns owners, sets timelines, and verifies completion. In AI contexts, corrective actions might include tightening retrieval access, improving logging and alerting, adding adversarial testing cases, or improving change control for prompts and model versions. Evaluating problem management means checking whether the organization learns in a structured way and whether improvements are actually implemented, not just discussed. A program that writes post-incident reports but does not implement changes is not reducing risk. Speed matters in containment, but speed without control can cause collateral damage, so a mature program balances urgency with safe decision-making. For example, disabling a model entirely may stop abuse, but it may also break business processes. So the program should have options for partial containment that reduces risk while preserving essential functions. Similarly, collecting evidence is important, but delaying containment to collect perfect evidence can allow ongoing harm. Evaluating this balance means looking for playbooks and decision frameworks that guide responders, so they are not improvising under stress. It also means checking whether the program has practiced AI incident scenarios, because practice reveals where control levers are missing and where coordination breaks down. Even for beginners, it is helpful to know that incident management is a muscle that improves with rehearsal. A strong evaluation asks not only whether playbooks exist, but whether teams have exercised them and improved them based on lessons learned. An AI incident management program should also consider external obligations, such as regulatory reporting, contractual notification requirements, and customer communications. A leak of sensitive data through an AI system may trigger the same reporting obligations as other data breaches. A vendor-hosted model incident may require coordination with the vendor, and the program should define how that coordination happens. Evaluating this area includes checking whether legal and compliance teams are integrated into the response process and whether the organization knows what triggers notification duties. The key is not to become a legal expert, but to recognize that AI incidents can have real-world consequences beyond technical systems, and fast containment must be paired with correct reporting and communication. A program that contains technically but mishandles communication can still suffer major damage. A mature program treats incident response as both technical and organizational response. As you conclude, remember that evaluating AI problem and incident management programs is about checking whether the organization can detect early, triage accurately, contain quickly, and recover safely, while also learning in a disciplined way afterward. AI systems introduce incidents that may look like normal usage, so tailored monitoring and user reporting channels matter. Containment often means restricting capabilities, disconnecting risky integrations, tightening prompts, or rotating credentials, rather than patching a server. Recovery requires restoring trust in configurations, data access boundaries, and model versions, not just restoring uptime. Problem management ensures that underlying causes are fixed so the same weaknesses do not keep producing incidents. When you can evaluate these elements and see whether the program has clear ownership, practiced playbooks, and real control levers, you are assessing whether the organization can keep AI risk from escalating into larger harm.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.